Video object segmentation allows computer vision to identify objects as they move through space in a video. The Davis Challenge is a contest among machine learning researchers who are working off of a shared dataset of annotated videos. The organizers of the Davis Challenge joined the show today to explain how video object segmentation models are trained and how different competitors take part in the Davis Challenge. This is a very important topic and will only get more important as self-driving cars come to be an everyday sighting, because if you have a self-driving car, it needs to be able to segment different objects that are coming into the video stream and identify pedestrians or other cars or anything on the fly. A good companion to this episode is our discussion of convolutional neural networks with Matt Zeiler, which is an episode that's linked to in the show notes. Software Engineering Daily is looking for sponsors for Q3. If your company has a product or a service that is marketed to developers, or if you're hiring, Software Engineering Daily reaches 23,000 engineers listening daily, and you can send me an email, jeff@softwareengineeringdaily.com. Thanks as always for being a listener to this show. Artificial intelligence is dramatically evolving the way that our world works. And to make AI easier and faster, we need new kinds of hardware and software, which is why Intel acquired Nervana Systems and its platform for deep learning. Intel Nervana is hiring engineers to help develop a full stack for AI, from chip design to software frameworks. Go to softwareengineeringdaily.com/Intel to apply for an opening on the team. To learn more about the company, check out the interviews that I've conducted with its engineers. Those are also available at softwareengineeringdaily.com/Intel. Come build the future with Intel Nervana. Go to softwareengineeringdaily.com/Intel to apply now. Federico Perazzi, Jordi Pontousset, and Sergey Calles are organizers of the Davis Challenge. Guys, welcome to Software Engineering Daily.
Hey, Jeffrey. Thanks for inviting us.
It's great to have you here. So today we're going to talk about video object segmentation and the Davis Challenge, which is a competition around video object segmentation. Let's start by describing the problem of video object segmentation. What does that mean?
So video object segmentation is a computer vision task that aims to separate foreground objects from background regions in videos. For example, I can tell you an example. You have a lion running in the wild. You want to take the segmentation of the lion, meaning that you want to delineate the contours of the lion in order to separate it from the background, which is probably like the savannah, whatever, in Africa. The idea is that video segmentation belongs to the bigger umbrella of like video understanding related tasks, right? So you could see segmentation like video object segmentations related to video classification or object localization. And it's all about extracting information from videos.
So if I have a video of a lion running across the savannah with a bunch of grass and trees that are occluding the image, or I've got footage from a self-driving car and there's lots of other cars around, and I want to separate a pedestrian from the other images in the video feed, and I want to be able to track that pedestrian specifically. These are some of the types of applications where video object segmentation might be useful.
Absolutely. So for the task of self-driving cars, for example, you can decouple like the localization of the pedestrian with the segmentation. The localization means, okay, you teach an algorithm to find out where the pedestrian is and to basically place a bounding box around it, right? Now, the bounding box is a rectangle basically enclosing the shape of the pedestrian. But to get even more information, right, to get more accurate information, you want to basically classify each pixel within this bounding box, whether it belongs to, the street or the pedestrian. And this is where, for example, video object segmentation comes in place.
Mm-hmm. So when we're trying to do object segmentation within a video, I mean, if you take a video of the savannah and you think about all the objects in the picture, you could break it up into blades of grass and trees, and you could go infinitely granular. You could go down to the molecular level. So how do you define the bounds of what is being defined as an object? What is being segmented?
Well, in this particular case, we have our own definition of object to be segmented, which is basically a moving object. How would you say? It's a moving object which is with dominant motion, right? This is our definition of object with respect to the foreground. But this is, again, it's like a subjective definition, right, that we decided. So in the challenge, for example, we provide the input object, right? We tell the user which object do they have to segment, which is the lion and not the grass. In general, right, there is an extension, we could say, or something really similar to object segmentation, which is called semantic segmentation. And this aims to classify each molecule, which is basically a pixel of an image, right, with a label. So in this case, the task of semantic segmentation would be like to classify each pixel belonging to the lion and each pixel belonging to the grass. And that basically gives you full knowledge of the scene, right? But yeah, sorry, Jordi.
No, sorry. Well, from a more philosophical point of view, I would say, so semantics lie in a hierarchy, let's say, in a hierarchy of concepts, let's say. So you can start by saying that that's a savanna, so that the whole image can be represented by that. Then from this would be like the parent of everything, the parent node of that hierarchy. And then you can start breaking this up step by step and saying, well, this savanna, there are like the foreground and the background maybe, or the animals and the plants. And then within that, we can say, well, there are the elephants and the lion there. Within the lion, you can get in still deeper and there's a head, and then there's the foot here. And then within that, you can iterate that until you get to the molecules, as you were saying. As Federico was saying, well, in our case, we define which level of this hierarchy you want to go by saying this is the specific object that we want you to track, because we are giving you this object on the first frame in the case of the Davis challenge. But in general, you would need to break the scene into this hierarchy that we were calling about, and that's why sometimes segmentation is said to be hierarchical, because you can break it into all these levels of concepts, from the molecules to the whole scene, let's say.
So in this challenge, the task is you've got, let's say, a video. I mean, in reality, you have a set of videos that you can run this out your own algorithm on. But the general problem is you've got a video, and let's say it's 1,000 frames, and the first frame is densely annotated, which is, let's say you've got a picture of a skateboarding park, and you've got a single skateboarder his entire outline is colored red, so you can understand exactly what are the contours of the object that you want to track. And then in the other 999 frames after that, it is not annotated. And the job of the algorithm that everybody is writing to try to compete in this challenge is to be able to track the object that has been annotated in the first frame throughout the rest of the frames. Is that an accurate description?
Perfectly accurate, yes.
Okay.
So
go ahead.
But let me do a little. So you said that it was densely annotated in the first frame. So we do a distinction here. We say that Davis is densely annotated because it's annotated in all the frames. So if you have 1,000 frames at 20 frames per second in a video, for instance, you have all those 20 frames in a second, all of them annotated completely densely. That was one of the main differences from our work to previous approaches, in which only 1 out of, say, 20 or 1 out of 30, so only 1 in every second frame was really annotated, and then that limited a lot how the algorithms were evaluated and were trained on this dataset, because you had a lot of holes into the annotation, let's say. So we say that we are densely annotated because we annotate all the frames. So that's one of the dimensions. Then the other dimension that you were saying is that at every frame that we are annotating, we have pixel level accuracy. So we also differentiate from other databases in the sense that we say that they are pixel accurate in the sense that they are really, really low level, precise contours of the objects here. Not only like a simple polygon around the object or a bounding box would be the worst case. In our case, every single pixel has been looked for by a human and has been decided whether that was foreground or background. And so you can really have a very, very high precision on this end. So at every pixel, at every frame, we have pixel level accuracy, and we have a densely annotation in the sense that so every frame in the sequence is annotated.
Okay. So you have described the competition, and I'll probably ask you to describe it a little bit more, just so people can get acquainted with it more, because people who are hearing this for the first time. But let's step back a bit. So the Davis Challenge, which you guys are a part of, is this competition for video object segmentation. So take a step back and describe the rules of this competition. What are the parameters, and who enters it?
So, well, basically, anyone is welcome to enter, either universities or companies. Anyone is welcome to enter. It's just we have a CodaLab website in which you can just simply register. Then you can download all the data set, the annotations for the training set, and then and also the images and the first mask, the annotation of the first frame of each video sequence. Then you can process it offline, and then you submit online your results. And the algorithm and the server just replies to you with your performance on the test set, let's say.
So okay, so I think this clarifies things. So if I'm a competitor, I download the dataset, and the dataset has that, like I said, like 1,000 frames, and then the first frame is annotated, and then the rest of the frames are not. But on the back end, you have all of the frames annotated so that you can measure the performance.
Exactly. Yeah.
Well, I mean, we also give like a training set, which is fully annotated, and a test set for which we only give one annotation in the first frame, right?
Right.
So the competitors are allowed to use like the densely annotated videos during the training phase, and they can only test their performance given the first frame, right? Of course, in the backend, we have all the annotations, and we can measure the performance like over the entire video.
Mm-hmm. And on the back end, you also have more fully annotated sets that are not disclosed at all to the competitors, right? In case they write an algorithm that overfits for the data set that they were given.
Well, for this, we have... So let me explain exactly all the sets that we have. So first of all, we have what we call the trainable set, which is like, in our case, are 50 sequences for training, 40 for validation. So these 90 sequences, you have all the frames and all the annotations for all the frames, okay? This one, you can use it however you want to train your networks, to tune your algorithms, and you can use it offline. Then we have another set of 30 sequences. That's what we call the test development, let's say, in which they are already available now. And for these ones, you can download the whole videos, the frames, and then only the annotation of the first frame, so that you cannot train on the frames that are evaluated afterwards, right? But we call it test development because you can submit as many times as you want your results. So you can really try it, and you have a number, you say, well, it's good or it's bad, you try another parameter algorithm, you submit it, and you can submit it as many times as you want without having the annotation. With this, as you said, people could overfit to it, could really tune the parameters of their algorithms to really improve, and let's say by brute force solve the algorithm. But to try to avoid this, what we have is another 30 sequences. So in total, we go up to 150. And these last 30 sequences, for now, nobody has them. So we have them on the backend only. Nobody has the annotations, and nobody has the sequences. And they will only be released for 1 week during the challenge itself, and that's why we call this one the test challenge. These ones will be 30 sequences in which we will always also release only the annotations of the first frame, and then people will have only 5 trials, so they will only be allowed to submit 5 times to the server, And that's the one that will be finally the results of the challenge will be evaluated on these last 30 sequences. Since people will only be allowed to submit 5 times, and since they will only have them for 1 week, let's say, we believe that with this we are preventing people overfitting to it. If people overfit to the test development, well, we don't care that much, because then for this final competition, they will only have this set 5 times and 1 week to submit.
At Software Engineering Daily, we need to keep our metrics reliable. If a botnet started listening to all of our episodes and we had nothing to stop it, our statistics would be corrupted. We would have no way to know whether a listen came from a bot or from a real user. That's why we use Encapsula to stop attackers and improve performance. When a listener makes a request to play an episode of Software Engineering Daily, Encapsula checks that request before it reaches our servers and filters bot traffic, preventing it from ever reaching us. Botnets and DDoS attacks are not just a threat to podcasts. They can impact your application too. Encapsula can protect your API servers and your microservices from responding to unwanted requests. To try Encapsula for yourself, go to encapsula.com/sedaily and get a month of Encapsula for free. Encapsula's API gives you control over the security and performance of your application, whether you have a complex microservices architecture or a WordPress site like Software Engineering Daily. Encapsula has a global network of over 30 data centers that optimize routing and cache your content. The same network of data centers that is filtering your content for attackers is operating as a CDN and speeding up your application. To try Encapsula today, go to encapsula.com/sedaily and check it out. Thanks again, Encapsula. As we said, every object in these videos that we're going to be tracking is annotated with an object mask. And annotation, I think when people think of the word annotation, they think of a text annotation. But this is actually a contour. It's like an outline or a mask. I mean, describe what an object mask is, because I think people who are listening to this probably still might be having trouble understanding what it actually means to have an image or to have part of a video be annotated.
Okay. Yeah. Sorry. So yeah, annotation can mean a lot of things, as you said. What we understand in our case is, as you said, is a mask. So an image is a matrix. Let's say is a bidimensional set of pixels. So it's a set of pixels, and a mask for us is just dividing this set of pixels into 2 sets. These pixels are object. These pixels are background. So for us, an annotation or it's a mask saying this set of pixels is background, this set of pixels is foreground. You can see it as a binary image, black and white, in which black is background, white is foreground, and each and every pixel has a value, either 1 or 0, either black or white, in which it says whether it's the object or it's the background. So each object is one of these masks. But let me point out now here one of the differences between Davis 2016 and Davis 2017, which is that for Davis 2016, as Federico said, we had a single object with dominant motion, and so we had a single object per video, right? In the 2017, we've added one of the challenges, another challenge, that it's that we have multiple objects per sequence. So every sequence has multiple, for instance, persons, has, as you were saying before, the skater, we have annotated the skate and the person. So we have multiple annotations or multiple masks for every frame, for every sequence, and then the challenge is not only to track one of these objects, but multiple of these objects in a single sequence.
Mm-hmm. So you're describing in the 2016 competition, it was if you had a video of a pedestrian walking on a busy street, you could annotate that image. So if you just look at every pixel, and if you assign every pixel a 0 or a 1, all of the pixels that include the pedestrian you might mark with a 1, and all of the other pixels you might mark with a 0. Now, in the 2017 competition, on that busy street, maybe there's also a car, and then you would mark the pixels that have the pedestrian with a 1, the car, the pixels with a car you would mark with a 2, and then all of the other pixels you would mark with a 0 if you were annotating that.
Yes, but so what you described is something like we assign the semantic, right? So to each of the pedestrian, we assign a 1 because they belong to the same semantic class. While to the car, we assign 2, right? Because it belongs to another class. Instead, no, in this challenge, to each pedestrian, we assign a different label. So we discriminate the instance, right? So the pedestrian is the object, and there are multiple instances of this object, right?
Oh, okay.
You see the difference. This is like, it's a bit like between, I mean, the lines are fuzzy, but it's like something in between semantic segmentation and instance segmentation. Semantic segmentation, you associate a pixel to a class label. Instance segmentation, you associate the pixel to the number of instance, right? So if you have 5 pedestrians, it's going to be 1 to the first pedestrian, 2 to the second, etc.
So this challenge is semi-supervised. So people who are familiar with machine learning might understand why it's semi-supervised, but for people who are not familiar with machine learning, explain why that term semi-supervised applies to this problem structure.
So, yeah, I mean, semi-supervised can be understood in many ways, and it can be misleading in our case also. So, but in our case, so we give a very specific definition of why we say it's semi-supervised, and it's because we need the input of the first frame. So we say we give you the input of the mask that we want to track on the first frame. That means that there's a human interaction in there that has to annotate something in the sequence, right? The first frame. When we call about in generic in machine learning, when we call supervised or unsupervised, it's whether the algorithms for learning, they have this annotation, this interaction of the human, whether they take it into account or not, right? For example, let's say the first the start of computer vision, where we were detecting edges, let's say by canny with the canny edge detector, let's say we were just doing an edge for us was something that the intensity color from one pixel to the other changed a lot, right? That's completely, we would say, unsupervised, because it's just, we define a set of rules, and it's not even with machine learning, let's say. But supervised would be, in this case, to take a set of annotations of what you want the result to be, in this case, edges, and then apply machine learning and learn from that. So to unsupervised, so when we were saying semi-supervised was just to separate from the unsupervised case, in which you are given only a video and you expect the algorithm to take the segmentation out. That would be our unsupervised view of video segmentation. We call semi-supervised as we are giving you the mask of the first frame. That's why it's supervised. And then we are asking you to give the rest of the frame, the rest of the annotations of the frame.
So if you were to take, like, let's say, you're talking, so the semi-supervision, the first frame is supervised. It's heavily annotated. If you were to annotate 2 or 3 more frames, does that make the accuracy go up? Does that significantly make the programmer's job easier?
Well, it depends on the algorithm, right? Because there are some algorithms would not make any use of multiple annotations. Some others that use like training, that train, for example, online, given the available ground truth, that for sure, that would like increase performance. There are a couple of examples of papers that recently came out to CVPR, which exploit like the first frame annotated. And I think they demonstrate that given more annotation, the performance rapidly increase.
So we did a show recently about Clarify, which is an image recognition and video recognition API. We discussed some of the basics of convolutional neural networks and edge detection, and then figuring out what an object in an image or a video might be after you take these edges, and then you sort of abstract to higher and higher levels to understand what these edges might compose. And so I'd like to talk about some of the algorithms that that might be used in this competition? Because we've been talking about the structure of the problem, like what is the way that the competition is laid out. So now I'd like to discuss some of the approaches that competitors might take. So maybe let's start with, what are the most naive strategies for approaching the densely annotated video segmentation problem?
Well, the most naive strategy, you take the first frame and you copy to all the others' frame. That would be the most naive strategy, which still might give you reasonable result if the object is like only moving around like, an anchor or something like
So
this.
if it's a sloth.
Exactly, that would be great. A better approach would be compute the relative motion between the two frames, right? So if you can you can estimate optical flow, which is a technique for computing like a mapping between pixel of the frame at time 0 to time 1. If you have this motion, if you have this information, you can propagate the mask forward. And this is also would be a naive way to compute the segmentation, while it could actually give some reasonable results. It's a baseline, I would say.
Okay, then what are some more sophisticated strategies?
Well, more sophisticated strategies the most promising right now, and then I'll let Sergey and Jordi also comment on that, but the most promising strategy, for sure, they use like deep networks, right? The best results that were reached in the 2016 dataset, they were all using like deep convolutional networks, deep architecture designed for segmentation of static images. Of course, the problem on video segmentation, it's a bit more, it's not more difficult, but video gives you more information, right? And you want to leverage this information. So I assume that many of the competitors will try to leverage, multi-frames. For example, they could try the previous information that is given, that is like estimated at the previous frame. So for example, they could have convolutional neural networks with feed-forward networks, with recurrent neural networks, right? Like LSTM, to remember what was the mask at the previous frame and leverage this information to the next one to get more accurate segmentation. I don't know what.
Yeah, this is, let's say, of course, the general, and I think that's not only for video segmentation, but for all fields in computer vision right now. It's been invaded by these convolutional neural networks that we all talk about. That's definitely the case also in video object segmentation. And so I would say that there are two main approaches, I would say, right now that are leading the competition, I would say, in 2016. That would be ones that take this motion information into account and to try to propagate the information from one frame to the other. And the other approach that is, instead of propagating the information, just learn the appearance of one object in particular using a neural network, and so learn that I am trying to follow a person that it's with red trousers, and then at every frame, without having the motion into account, just look for this model and look for that particular model onto the next frames. But yeah, this is I would say the two leading approaches in the 2016. We'll see what we see in 2017.
So I think something that I have trouble with, and I think maybe a lot of the listeners who have trouble with, who are people who are just traditional software engineers, they've just been writing business logic, and maybe today they're trying to get into machine learning, or they're at least trying to build an understanding of what goes on in machine learning. The idea of like these multi-layer networks where you have sequential processing in these different layers, and you're handing off information from one layer to the next layer, and then there's some sort of feedback loop where it's learning over time how to do this better. It feels like a very foreign type of programming. Can you just give us, I'm trying to get better at having shows about deep learning, but I really don't have a great understanding of it. But can you give me an understanding of how information propagates from one layer to another? How are you representing it in code? And yeah, just describe the process of building a convolutional neural network for a software engineer who is not an expert in this.
So basically, it's quite, so there are a lot of maths behind, but there are some frameworks that help you to do that. So you don't have to go to really the deep level, to the really core level of multiplications of matrices. And so, for example, like there is like the first one of the first frameworks that pushed the deep learning was like Cafe, that we are like still using. But then many companies also approach this and they try to do their own like framework. For example, the one right now that is pretty famous is TensorFlow. But mainly all these frameworks, what they try you to do is like make your life easy and like try to describe one of these convolutional neural networks in 10 lines or like 20 lines. Because otherwise, if you had to write by hand like all the matrix multiplications that are behind the scenes, it would be more tricky. And to do currently one important thing that boosted the deep learning community and all the performance of the algorithm was the usage of GPUs, because all these the multiplications of the matrices, the convolutions, can be parallelized. So like GPUs are like the perfect fit to implement this kind of algorithms.
So, but let me just say that if you want to write a naive implementation of a convolutional neural network or a neural network, let's say, this is just a bunch of matrix multiplication and transpose, right? Plus some nonlinear function like exponential function or the tangent. But as Sergi was saying, of course, there is a lot of optimization, right? And you need that to leverage the massive amount of data that is available right now. So as he said, there's now like better way than implementing yourself, like TensorFlow or Caffe.
Mm-hmm. So if I'm a user of TensorFlow or Caffe or whatever, just describe my workflow. What does that actually look like? So for example, if I'm approaching the problem of densely annotated video segmentation, what is a day in the life of a programmer who's writing a model trying to solve that problem?
So usually you have like a certain architecture, like for example, one of the most used like ones is BGG, and then you take like, so there are like many parameters in this architecture, in these neural networks, and then in order to achieve better performance and to need less data for the task that you want to currently approach, usually you do what is like called pretraining. So you take the network that was trained in for another task, for example, object detection or
image labeling,
and then you use that information into your problem and you just like fine tune. That would be like adapt the neural network architecture to your specific problem.
So for somebody like me who is trying to get an understanding of deep learning, what would be your suggestion for the best resources? Because I know there's like an overwhelming amount of resources. Is there some particular tutorial or set of papers or book that is the best place to start?
So there are many resources. Like for example, there is one researcher, Andres Carpati, that has like many, for example, blog posts where he tries to explain in quite an easy way and give examples of how this works. But there are also, in my case, I found quite useful online, these massive online open courses, like for example in Coursera or Udacity, where there are like many courses where you can actually learn.
Right. Okay, so let's get back to the Davis challenge. Describe the phases of the competition.
So right now we are on the phase of the test development that we call. So it's from now until June. And in this one, people can download the current dataset, so the 30 sequences of this phase, and they can submit. So publicly available, there's only the annotation for the first frame, and they can submit as many times as they want their results onto the server and get the evaluation as many times as they want. That's what we call the test development phase. It's for people to tune their algorithms to unseen sequences. And then in June, for a week or 10 days, we will have the test challenge itself, in which people will only be allowed to submit their results 5 times. And from the best of these submissions, it's where the winner of the Davis Challenge will be decided. And then in CVPR 2017, this year in Hawaii, we will have a workshop in which we will gather all the submissions, and we will also have some very good keynote speakers, and we will discuss about all the results that we've got, how people approached it, discuss what worked, what didn't work, and then give the prizes also. So think about what to do next and what to do for Davis 2018.
Who are the people that are entering these contests?
Well, I guess researchers from universities, like PhD students. There might be also like single individuals interested in the topic. Well, of course, our challenge doesn't give you the exposition of a competition on Kaggle.com, for example, this big machine learning like website. But, you might also gain some visibility. We had good sponsor. We're going to have a presentation. So I guess we will have an heterogeneous like population of like competitors, right? From different backgrounds, like.
Yeah, well, I would say in general researchers, but both from academia and from industry, I would say.
Spring is a season of growth and change. Have you been thinking you'd be happier at a new job? If you're dreaming about a new job and have been waiting for the right time to make a move, go to hired.com/sedaily today. Hired makes finding work enjoyable. Hired uses an algorithmic job matching tool in combination with a talent advocate who will walk you through the process of finding a better job. Maybe you want more flexible hours, or more money, or remote work. Maybe you want to work at Zillow, or Squarespace, or Postmates, or some of the other top technology companies that are desperately looking for engineers on Hired. You and your skills are in high demand. You listen to a software engineering podcast in your spare time, so you're clearly passionate about technology. Check out hired.com/sedaily to get a special offer for Software Engineering Daily listeners. A $600 signing bonus from Hired when you find that great job that gives you the respect and the salary that you deserve as a talented engineer. I love Hired because it puts you in charge. Go to hired.com/sedaily, and thanks to Hired for being a continued long-running sponsor of Software Engineering Daily. It is interesting that there are some problems where the idea of competition and crowdsourcing really make a lot of sense. Like, I think, machine learning, where you have these data sets, but it's very unclear what is the best strategy because there's so many different strategies that somebody could potentially take. This is a good fit for a competition. Similarly, competitive programming competitions where they give you something like, here is 1,000 words from the dictionary and the description or the definition of each of these words, make the best compression and decompression algorithm specifically for dictionary entries. And, people take all kinds of different approaches. What do you think, what are the types of problems in computer science or software engineering that are a good fit for this crowdsourced competition model? Does my question make sense?
Yeah, so I'm not sure I fully understood the question. So what do you mean by crowd?
So my question is, if I'm an engineer at Google, for example, and I've got a minor bug to fix in Gmail, that would not be a good problem to crowdsource to the entire company and do a competition for, because there's probably not that many different approaches you could take to solving a bug. And then on the opposite extreme end, you've got something like densely annotated video segmentation, where you've got a giant data set, you've got a million different approaches you could take, and then in the middle, between those two different types of problems, you've got a huge array of different types of problem sets where there's varying degrees of subjectivity. So what I'm wondering is, like, what classifies a problem in computer science or software engineering as being something that is approachable from the wisdom of the crowds? Because that's essentially what you're doing with Davis. It's a wisdom of the crowds approach to let's try to find the best way to approach this video segmentation problem that is super important. Like, let's be clear, this is a super important problem for computer vision. Specifically, I mean, the self-driving car thing I think is the most important thing that comes to mind, but obviously it's important for drones and like a whole host of other problems. And so I guess my point is just that there are problems that are great for crowdsourcing, and there are other problems that are not. And I'm wondering, what is the general case of a problem that is a good fit for the crowdsourced solution?
Well, okay, so in my opinion, every problem for which you don't have a solution is good for crowdsourcing.
Okay.
Whether, you're looking for a fastest sorting algorithm, right? It can be, if you look like for, of course, as you said, right, machine learning doesn't have an analytic solution, right? So there's going to be a lot of people trying to make ensemble of different strategies, which in general are the one who wins this competition. And, different flavors, different nuances until, someone gets best results. But even analytical challenges could be like finding, there are prices in physics, right? That have been there for 100 years. I don't remember the names now, but for example, there's this popular, right? If you prove a theorem, then you get money for it, right? So every problem which doesn't, this is the way I think about it, it's a different business model, right? So before it was okay, we'll try to solve the problem ourselves within the company, right? Now what happens is that, wait, if we don't solve the problem, if our 10 engineers don't solve the problem, we're not going to make money out of it, right? We're not going to be able to make the product that we want. So how about in first place, we share the knowledge that we have to make it easier to the others to solve the problem. And next, we basically provide with the data and all the possible tools in order to the wisdom of the crowd to find a solution for it, to find a better solution. And this is why, for example, I think this is all related to all these APIs like TensorFlow being publicly available to everybody, right? Why before would a company make their best tools available to everybody for free? Because now crowdsourcing is a different business model, I think. It's a different way of carrying out business.
I was doing a bunch of shows where I was asking people the question of whether we should be worried about AI risk or whether it is something that is, as Andrew Ng said, the risk of overpopulation on Mars, where you don't need to worry about AI risk. You don't need to worry about or in the near future, you shouldn't be worrying about the AI rising up and wreaking havoc on the world. And, that question I think is an interesting question. But what I'm starting to realize, I think, is a more pertinent question is, I'm looking at these things like the vision, the generative convolutional neural networks, where you can recreate video based on a large sample. I was looking at some stuff that came out of SIGGRAPH recently, or just some videos from projects that are going to be talked about at SIGGRAPH. I think that's an upcoming conference. But there was something where you can take a large sample of Trump videos and recreate new videos of Trump talking. And it's quite clear that this is going to become a problem. This is going to be something really confusing in the future, where we're going to start to see videos that are really convincing but are manufactured, generated videos. And I guess my question is, are you starting to have conversations with people about how to maintain the ethics in this type of environment, or how to maintain veracity for videos?
So I never had this type of conversation, actually.
Okay. Is it? If you guys don't want to talk about it, I mean, I realize this is kind of outside the bounds of your work, but it's just something that's been alarming to me recently.
Well, yeah, no, you're right. I mean, I also think, in some sense, I think about it for example, what's going to be about art, right? What is the human touch to art, right? Art meaning writing books, making music, generating videos, pleasant videos or something, right? We're talking about computer vision, but now the same neural networks generate music really well.
Yep.
So are we going to need musicians? Or, it's a bit, I don't know how to take it, honestly. I'm thinking about it once everybody. I never had talk in the office about it, but Uh, I'm not personally like.
In my case, I'm on the side of not worried at all, let's say, in the sense that, of course, our lives will change a lot. Our lives will be much different, but we will adapt and we will survive, of course, to AI, and I wouldn't be worried at all. But of course, as you were saying, maybe I would bring the discussion to a more concrete level and to a more specific level. And for instance, we were talking about self-driving cars, right? And
Right.
well, that problem that we were saying, whether like the machine has to decide whether there's a risk situation, whether to kill, let's say, directly some pedestrians, 3 pedestrians, or whether and save your life, or whether to kill yourself and save those 3 pedestrians, right? Those are things that are more, to me, more tangible, more on the near future, and that we will have to code it somehow, and we will have to decide it somehow, and that's what can be like really more interesting to me to decide, right? Whether you take the greater good, let's say the global good of society, versus the private good of you saving your life, right? And what I worry is that it will come down, as a lot of things, it will come down to money, right? And I wouldn't like to see it, but it could be like, depending on the package that you pay or how much you pay, the chances of you surviving will be more or less, right? And right now you have it somehow because you have better cars, and theoretically with the better cars you're have less chances of dying, let's say. But now you will have it in more, let's say, coded somehow into the neural network, and that's what at least will create a lot of discussion, and I would say very interesting discussions.
When we're talking about this stuff like self-driving cars and image recognition, does the public research field and the university research field, does that represent the cutting edge, or is the cutting edge of this technology sitting behind closed doors in a corporation?
Well, I think the cutting edge is in the research actually, and companies are following up on that. I mean, it has to be like this for many years. I guess the gap is closing right now in the sense that the companies are closer to research, but the cutting edge, you see it at conferences, right? Not within the closed door of companies. I think in the closed door companies, what you see, it's a lot of optimization and making things works, right? Which is as important as making the initial research, I guess, but it's a bit different.
And I would say that right now this line is being blurred a lot by a lot of companies investing in open research. But I agree with Federico that let's say the things that will work in 10 years times in companies are the ones that people are in universities and research in general are researching today, right?
So I guess let's close off. What are you guys most excited about in this space of video object segmentation, being able to track images in video over time? Like, this is a massive tool if we get it right. What are the applications that you're most excited about, and what else in this space are you most excited about?
Well, applications, of course, like low-level, like video segmentation serve the purpose of like other high-level applications like self-driving cars, like video surveillance, for example, like action recognition. So there are many computer vision related tasks for which video segmentation might be used as a pre-processing step. For example, from a visual perspective, for example, for the visual effects industry, video segmentation is a fundamental tool, right, which would cut the cost of rotoscoping. Rotoscoping is basically the task of artists to basically separate, again, foreground object like actors from the background, right? So having a reliable video object segmentation algorithm would basically allow the movie industry to get rid, for example, of the virtual green screen, right? So that would be like a massive improvement for the movie industry. It would help to cut the cost like significantly.
What about you other guys?
Well, I mean, for me, of course, so Federico comes from Disney Research, so yeah, I mean, he is aware of all the industry problems. In my case, I am, as we said, more focused, more interested in the self-driving cars, as you said, it's a clear situation in which right now it's a hot topic, I would say. Also, like robotics, let's say being able to a robot to really grasp. So you can tell, like, for instance, an assistive robot for handicapped people, let's say, go grab that cup of coffee, or so really being able with computer vision to really know exactly where that object is and segment it and track it over time. That could be a breakthrough also in robotics, right? To lower the prices of the sensors, that with just a webcam or just a camera you could do all that, right? So definitely a lot of exciting applications.
All right, guys. Well, I want to thank you for coming on Software Engineering Daily. It's been great talking about the Davis Challenge and video object segmentation, and I look forward to seeing the results of this year's competition.
Thank you very much for having us.
Okay, great. All right, thanks, guys. This was great. And I think there was one of you that didn't answer the last question, but I don't know if it did. Is that okay? Did you want to answer it?
Yeah, no, I can follow up a little bit on Jordi's answer. Like the robotics part for grasping objects, it's crucial to have a pixel-wise annotation and not just bounding boxes. Otherwise, it's not it would be difficult. And also with the drones, that in order to track people, to follow people in the videos, or also if they have to do any kind of manipulation with also a robotic arm for repairs and
right,
or something like that.
Right, that's going to be huge. I can't wait till a robot can just fix my sink. Anyway, cool. You have a full-time engineering job. You work on back-end systems or front-end web development. But the device that you interact with the most is your smartphone, and you want to know how to program it. You could wade through online resources and create your own curriculum from the tutorials and the code snippets that you find online, but there's a more efficient option than teaching yourself. If you want to learn mobile development from great instructors for free, check out CodePath. CodePath is an 8-week iOS and Android development class for professional engineers who are looking to build a new skill. CodePath has free evening classes for dedicated, experienced engineers and designers. I can personally vouch for the effectiveness of the CodePath program because I just hired someone full-time from CodePath to work on my company, Adforprize. He was a talented engineer before he joined CodePath, but the free classes that CodePath offered him allowed him to develop a new skill, which was mobile development. With that in mind, if you're looking for talented mobile developers for your company, CodePath is also something you should check out. So whether you're an engineer who is looking to retrain as a mobile developer, or if you're looking to hire mobile engineers, go to codepath.com to learn more. You can also listen to my interview with Nathan Esquinazzi of CodePath to learn more. And thanks to the team at CodePath for sponsoring Software Engineering Daily and for providing a platform that is useful to the software community.